let's do this one. So let me erase these numbers. All right, cool. So here, if we go from left to right, looks like we would give the substituent really high numbers. So 1, 2, 3. So if I go from left, it would give this guy um, carbon number 1, 2, 3. But if I go from right, I would give 1, 2. So a lower substituent number to this methyl group. And it looks like we have now a ethyl substituent here too. Here's the ethyl and there's a methyl. So let me number these carbons. 1, 2, 3, 4, 5, 6, 7. So we have a heptane. We're dealing with a heptane group. Um, and we have a methyl on carbon number 2. So 2 methyl. And we have an ethyl group on carbon number 5. Ethyl group. So naming this, we would need to start with, and we need to go with the alphabetic order. So E comes before M. So I would start naming this with the ethyl. So 5 ethyl, 2 methyl, and we have a heptane. All right, cool. So let's move on to something a little different. This is involved naming as well, but this is a stick model of carbon linked chains. And at first, this is a little confusing to look at. But again, this is a stick model, a little more simplified. We don't see any hydrogens, just sticks that represent carbons. So again, here, same idea. I would want to look for the longest chain, carbon chain. So let's go from left to right. 1, 2, 3, 4, 5, 6, 7, 8, 9. So going from left to right would get 9. But how about if I go from left and then go up? So yeah, let's do that. 7, 8, 9, 10. So I would get 10 going up. So I'm going to go with that one because that gives me the longest chain. And I'm going to erase these actually. So, all right, so let's now look for our substituent groups attached to this chain. Looks like we have a methyl, another methyl, and looks like we have a isobutyl group here. Yep. So let me first give you the parent chain name. So 10 is a decane. We have a methyl on 2 and a on 3. So that's a dimethyl. And we have a isobutyl group on carbon number 6. Isobutyl. So how would we name this? I would, again, alphabetical order. I comes before M. So I would start with isobutyl. So 6 isobutyl, and then 2, 3 dimethyl decane. All right, we're done with naming alkanes. Now let's move on to actually doing one problem relating to constitutional isomer of alkane. So if you're given a something like find certain amount of isomers of this compound that has, for example, here 6 carbons and 14 hydrogens. Usually in organic chemistry, um, you would want to find the degree of saturation, so du, and usually there's an equation that says du equals number of carbons minus 1/2 of number of hydrogens um, plus number of halogens minus nitrogen and plus 1. We have no hydrogens or halogens here, so I would write 6 minus 1/2 of hydrogens, which is 14, plus 1. Here we get 6 minus, here we have 7 plus 1, which gives us a 0. So we know, so the degree of unsaturation pretty much, we do have any, pretty much tells us that there is a double bond or a ring or rings involved in a compound. So here we have no double bond or rings, so we can move on just finding the constitutional isomers for this equation. So let's do the simplest. I usually want to start with the simplest. So we have a 6 carbon, it says, so let's draw the 6 carbon link. 1, 2, 3, 4, 5, 6. And automatically we can count there's about 14 hydrogens because there's 3 here, 2 here, 2 there, 2 there, 2 there, and 3 there. That's equals 14 hydrogens. So this is our first isomer. We need to find 4 more. So let's find our second isomer. So the way I would do this is probably start moving like carbon atoms around. But I would like to start with moving only one. So let's move this one here, this carbon here. So let's break it and then move it to this carbon. And to make it easy, I'm going to number them. So going from here, um, 1, 2, 3, 4, 5, 6. So let's move carbon number 1 into carbon number 3. So let me just draw that. 1, 2, 3, 4. We initially had 6, 5. Now we're going to have 5 link chain, and this was initially 2. Now it's this carbon initially was 2 here. Now it's 1, so I'm going to start numbering that. So 1, 2, 3, 4, 5, and this carbon here was initially 3. Now it's 2, and I've moved carbon number 1 uh, up to carbon number 3. So let me just draw carbon number 1 here. So here's our second constitutional isomer. Let's draw our third. So I moved this carbon initially to carbon number 3. Let's move it now again from here to now. Let's make this a blue. From here into carbon number 4. So how would that look? So 1, 2, 1, 2, 3, 4, 5. So let me number these actually. Carbon number 1, 2, 3, 4, 5. So I have moved it now to carbon. Initially, this was carbon number 4. Now it is carbon number 3. So I moved carbon number 1 to carbon number 3. So let me draw that. There we go. These all these three so far look different because you can see with the numbering, it goes from a straight line, and then there is a substituent now because we broke one of the carbons and moved it to carbon number 2, and then we moved it from 2 to 3, and now we have 3 different type of compounds, and these are constitutional isomers. So let's do number 4. We need 2 more. If I were to move this to number 4, it would actually give us back this original compound number 2 because so let me just draw that. 2, 3, 4, 5. If I were to move it from here to here, I would need to start numbering them again, right? From left now. 1, 2, 3, 4, 5. And it looks exactly like this one. So this doesn't work out anymore, moving 1. Now, I think it's good time to move 2 carbons around. So, um, so let me just draw. If I were to move 2 carbons around, the chain would decrease from 5 length to 4 length, right? So let's do that. 1, 2, 3, 4. So let's say we are looking at um, so let me number these actually. 1, 2, 3, 4. So if I'm working with 6 carbons, so far I have 4. Let's say I move I have 1 carbon here and another carbon here. Does this look similar to any of these compounds? Like 1, 2, or 3? No, it doesn't. Because this is a totally different compound. This is another constitution isomer, which works well here. So let's do one more, last one. I think this is the last one we can actually do for this compound, for this equation here. So still, I'm going to keep the 4-link chain and move things around. 1, 2, 3, 4. So if I move carbon number 3 to carbon number 4, I think I will get equation number 2, compound number 2, which doesn't work. But if I move carbon number 3 to carbon number 2, um, it looks a little bit different from the rest. So let's try that. So let me number it. 1, 2, 3, 4. We already had 1 carbon here initially, and you said we're going to move this guy here, and it looks like that. So this gives us a dimetal in this chain, 4-chain carbon link chain. So this is definitely different from the rest. So yeah, this is good. This is good. This is different. Good, good, good. And that's our 5 isomers for this equation.